So in this video, we're going to cover a few things. First, it's about the new OpenAI embeddings model. So if you're not familiar, OpenAI on December 15th announced a totally new embedding model that greatly increases the efficiency, lowers the cost. It's fantastic. And so this will walk you through how to use that new model. I also want to give you a concrete example with real-world data, and so for this I'm picking Markdown documentation for what we do the embeddings with. A lot of the big tech companies, Microsoft, Amazon, GitHub, to name a few, have their docs in Markdown format, or at least some subset of their docs, and so it can be a really rich data set to use and play with. And then also what we're going to do is, once we've created the initial embedding and then used search and cosine similarity, we're going to provide the result of that search as context to a completion call. So taking then text DaVinci 003, give it that added context when someone's asking a question. And it essentially allows us to get a similar result that you would for something that you would normally need a fine-tuned model for. If you have some corpus of knowledge that has data that is outside of OpenAI's models, and you want to be able to ask questions, and you want to be able to have chatbot return answers that are very human-sounding, in order for it to have your data, there's the two options. You can fine-tune your model, which can be very time-consuming and very costly. Another option is to basically perform a search of your internal knowledge base and then be able to provide that as context at the time of the completion call. So we'll go through that a little bit to make that a bit more clear. Also want to go through just give you a sense of, as you're working with small, medium, and then I'm saying large-ish data sets because large in big tech is very relative. So large-ish in this case is going to be into the millions of tokens, some of the things you'll start thinking about, but there are certainly much larger data sets than what I'm going to brush over here, along those same lines of when you're using these models, thinking about cost up front, thinking about how you scale, and thinking about rate limits, which is going to come into play depending on how much data you're sending and how quickly. So to start out, I have this little script I wrote, which the whole purpose behind this is I have a folder that has some Markdown files, and we'll show you this folder. The Markdown files are not just at the root, they are under subfolders, and so this is a very basic script to go through, and regardless of the number of subfolders there are, it's going to keep going deeper until it gets to the bottom. Anytime it encounters a Markdown file, it's then going to do a little processing on it, and it's going to add it to a list that I'm creating and be able to go and add that to a data frame. And so the way that I'm doing it is each file will become essentially two rows in a data frame, one with the file name and then one with the full content text. I am doing a tiny bit of pre-filtering on it, where any of these files, if you've not seen one before, some Markdown files have a particular structure, and in this case we have metadata at the top. I don't want to bring in metadata because of the token limit, so I'm just looking for these and pulling out that information. So basically I have a little search string, I'm going find. Anytime I have those, I can use a little counter to ensure that I'm not grabbing the metadata, but I'm grabbing every single other line of the doc. Certainly as well, if you were working with knowledge base that isn't in Markdown files, any file that is human readable in Notepad, you could adapt this script to be able to use. So if you have a bunch of text files, if you have a bunch of HTML files, you could change the file extension, you could add additional file extensions, and then certainly just remove or modify the checks that are going and pulling out metadata. And so we'll run this really quick. Runs pretty fast. We'll generate a data frame based on that. And so now we have 27 articles, indexed by 0, file name in this column, and then here the entire text of the doc is here. You can see we have some new lines and some things we want to pull out. Going to do some basic normalization. This is certainly not thorough. I'm also pulling out the pound sign just because that gets used in the headers within Markdown. ultimately you'd want to do way more cleanup than this, but this is just to give you a sense. We'll run this, clean this up. If you've used embeddings in the past, you probably used the Hugging Face Transformers library for tokenization, which has its own GPT-2/GPT-3 tokenizer. Now, with the new embeddings models that are from OpenAI, you need to use the CL100K base tokenizer. This is part of a new library, which is I'm not sure on the pronunciation if that's TikToken, or TIK token. We'll have to ask OpenAI. But if you do pip install, we'll say TikToken, you can then import it and use it. It's pretty easy to get set up. And so we'll use it here. So very similar to the old call we used to do, just in this case we have to use different library if you've ever done embeddings, and make sure you're using this tokenizer. And we'll go and apply that to our data frame. So we now have this end tokens column, and so this is the number of tokens based on the size of the content, the actual article itself. One thing I like to do is look at price, and so some of these prices you're not going to be using the old V1 models, but I think it can be helpful right now as people may have code that's running on the old V1 models to understand and appreciate how much cheaper it is to do things with the new Ada V2 model. So we'll run this. And so all we're doing is we're just taking this end tokens column, we're summing it up, and then doing a tiny bit of math based on the pricing on OpenAI's site to make this nice table and see approximate costs for things. So you can see even this relatively small data set of 27 articles, the old DaVinci V1 model would have been $11 US to go and run embeddings, which it really would not be sustainable to do. It would not be cost efficient, so it just wouldn't even be an option. Now with the new Ada V2, it's cheaper than everything we had before, which is amazing, and the performance is often as good as the DaVinci on embeddings and embedding search. So here we're going to go and generate our embedding. So this is just, we're going to take the text that we have in our content column and we're going to convert it into a bunch of floating point numbers that are a representation of that data. So we'll run this, and there we go, there's our data frame. And so you can see here's the Ada V2 embeddings column. So these are just large floating point numbers that represent this content. We can now do search. We also, so this is kind of a standard search. You can see that this is using as well. So both for the embedding and the search, we can now use text embedding Ada 002. Before we'd have to use a different model for each. And we're going to use cosine similarity based on, so we'll generate an embedding of whatever question gets answered. And right here, we're just taking user input. So we'll come up with a little question box in Jupyter Notebook. A question gets answered, that then gets passed, an embedding is created, and then that embedding is compared by cosine similarity to all the embeddings we already have of our docs content. So let's run this, and we'll return the top 3 results. And so now we get this little question box. I'm going to ask it a question that I know that we wouldn't be able to get otherwise without using our content, because we'll take that later. So we'll say we'll say, does Azure OpenAI support customer managed keys, also known as CMK, and question mark. And because I don't need to hit that because I'm using a text, I just need to hit enter because of the input field. And so you can see it came back with our 3 top results. It thinks that based on cosine similarity, this is our best bet. This article is on encryption at rest and customer managed keys, so that's what we would have wanted. And its second best choice was a what's new article that actually announces the support for customer managed keys. So both of these would be pretty good options. If we want to look specifically at the content that in this first top result, which is essentially the entire body of the article. So you can see here as well, there are things that we'd want to filter out. We could certainly winnow down this result to something smaller at the phase that we're actually going and bringing this in and before we ran embeddings. But for right now, we're just kind of having a one-to-one relationship with an article is then going to have all of its content rather than us kind of splitting that out into more smaller, easier to manage chunks. What we're doing here is we're going to take that same search that we did before. We're still going to ask a question, but now we're going to add some other fun things. So we're going to pass the result that we get. So whatever it sees as the top result will get passed to a variable we'll call it context. We're going to use text DaVinci 003 to perform a completion with OpenAI. We have a new initial, because we're doing a completion call now as well, we have our initial prompt that you might if you were just trying to do a chatbot with OpenAI. And so it's very simple, following conversation with AI assistant, helpful, creative, clever, friendly. And we're then going to create a combined prompt that is our initial prompt plus the content that we got back from our search, which in this case is going to be an entire article, and then plus Q:, and then the question is the question that whatever was. And so we need to also, so this is AI question, so this needs to be AI question. And we'll type our question again. Does Azure OpenAI support customer managed keys? Question mark. And enter. And you see now, rather than before where we just got back kind of this list broken down by similarities, now we get an actual response. So because we provided that context to text DaVinci 003, it's able to answer a question that I know is not in its model, but it's able to answer like a fine-tuned model would with the actual correct information. You can see that there is, in this case, it's saying you can learn more by looking at this documentation page. We're not actually referencing the documentation page, it doesn't have that. So there's definitely things to improve in that data set, or to actually include the link to the article that we were using for context as part of this response would be certainly another option. And if you want to see that full combined prompt that we're putting together here of these things, we'll go and quick print that. So you see our initial prompt of the following is a conversation, then the contents of that doc, and then at the very end, our Q:, with the question appended to it. So what I want to do next is go through the same process again, but with a slightly larger data set. So what we went through before was 27 articles. Now I want to go through the full cognitive services data set that is on things like it covers computer vision, deep learning, form recognition, anomaly detection, also the OpenAI content, but just a bigger data set. I think it's about 1,800 Markdown files, and we'll see just kind of how this script handles as we, and how the API calls, how we have to think about things as we scale up to larger and larger data sets. So we'll run as we did before. This, which is just going to go and grab all the Markdown files that it can find in this directory or any subdirectories. So it runs pretty fast. Create a DataFrame. So you can see we now have 1,842 articles. There's all the content from them. Again, as before, going to clean up some new lines and some other things, but ultimately, in a true scenario, you do a lot more cleanup on this data. We'll be using our new tokenizer as we did before. The other nice thing about this is we get the increased max input tokens, whereas before we were limited to 2046. Run this. All right, and so we now have our end tokens column. You can see when we have a larger data set like this, pandas is going to kind of truncate and not show us everything so that we don't have to scroll indefinitely, which is very kind of it. I believe it that we do in fact have other data here between 4 and 1,837. I'd like to know what this is going to cost, because this is on my personal OpenAI subscription, not anything corporate. So again, you start to see really the cost savings here of using the new Ada V2. So this for over 1,800 articles, it's going to cost me $1. Before for DaVinci, it would have cost me $500. Before, even for Curie, it would have cost me $50, which is probably, I wouldn't have bothered to do this experiment at a $50, at least not on my personal account. We'll go and take the length of the DataFrame really quick. We're going to drop some of these if they exceed 3,500 tokens, just to minimize. So technically this number is going to be a little bit less because the total token count now of the articles would be lower. But this just gives me kind of a baseline. I could certainly run this again, look at end tokens, but for me, I'm fine with that. Before we just went and then ran off and generated our embeddings, but now we need to, at least as we have this larger data set, we need to start thinking about rate limits. So for me, so if I was a free trial user, I would absolutely have to be thinking about rate limits, because at least depending on how I'm doing things, with how we did things in our mini example, we're not doing any batching. So we're sending one request at a time very rapidly, because when you do a apply in pandas, it does it quite quickly. It's doing it one at a time, so it's not parallel processing or anything like that, but it's still doing it pretty fast and getting back those responses. So free trial users, if they tried running the code that we had last time, you would hit a rate limit and it would bomb out. Pay as you go, for me, I just created this account on OpenAI within the past 48 hours. So I am going to hit this 60 requests per minute rate limit, because I'm also still not doing any sort of batching. So even though I technically can do 250,000 tokens per minute, because I'm going to be doing things, I am just sending one request at a time. And so this is some basic code to handle that. So if you want to do you don't have such a large data set that you're getting into the territory where you need to batch and have a single request have actually multiple embeddings in it, we can kind of get around that with this. So this is, and also certainly once I pass this 48-hour window, then I would still be fine with this particular data set, because then I'd go to 3,000 requests per minute. And since we're going to ultimately send 1,700 requests, we'd be fine. This is not the most complicated code, but just we have some counters. We set our rate limit here. I have this IPython display. I didn't want to be doing printing and have the screen going down, down, down forever. So this is basically just doing a clear on the screen every time through the loop, just so that we can see the numbers go up and see what's happening, but we're not having to deal with anything else. This code here, I'm going to comment out really quick, just because this was kind of a silly error that I saw, that what was going on was not intuitive to me, so I'm going to force it to have this error. But you can see we're just going to, once we hit our rate limit, we'll sleep for 60 seconds so that they don't shut us down, and we'll go from there, and you can adjust this as you need. I'm going to run this. And so this is going to fail out because there's something with my data that I need to clean up. I'm not going to do that right now, but just in case you see this error, because when I was searching, I did not find any instances of an answer to what was happening. And it's a fairly obvious error. But so what it says is blank is not valid under any given schema's input. And I can see that it's doing my embeddings. And so ultimately what this means is that somewhere in here of these things that I'm not seeing because of pandas being nice and hiding it for me for ease of viewing, I must have some content fields that are blank, which means there's something wrong with some of my intake script, or there's just some exception that I didn't think of. Maybe there's files that don't have metadata on them, and so I'm looking for that and then throwing things out. I need to go back and look, but essentially to make this work, I can go and say, if my content field, or in this case it's named text, if text is blank, just write the word blank to it and then print on the screen, blank content field detected. Ultimately, you'd want to clean up your data, because that means the way I'm doing this, I am going to be charged for a handful of embeddings for these fields that didn't process correctly. I know there's only so many of them, so I'm really okay with that. I'm going to go and hit run. And you can see it did detect some blank fields there, so the script would have, prior to this, it would have failed. We're now sleeping for 60 seconds because we sent our initial 60 requests. I'll stay with this for a moment. I'm not going to continue all the way through this. You'll get the idea. But this is really just to give you a sense of, as you start scaling up to a slightly larger data set, you need to think of how you're handling those embeddings. And so you can see what happens once we're done sleeping. We reset, our total request is going up. but our mini request counter will get to 60, then the script will sleep again. We don't need to watch all of this, and essentially the rest of this is the same as what you saw before, but this is just to give you some very basic code if you need to handle the rate limits, but don't necessarily want to do some of the more advanced solutions. Going to go over to large, and so in this case, what we're going to do is we have in temp storage, we have all of the articles that exist in Azure Docs. So basically Microsoft has their most popular repo, it looks like, is, or one of their most popular repos is Azure Docs. And so I have a copy of that locally that I'm going to go through and chunk through just so we can get a sense of what it's like when we're playing with a larger data set. And so we will suck in every Markdown file and every article. I don't necessarily recommend forking the entire repo unless you have interest in contributing to docs because it's quite large. But we're going to quick go through and process through all those files. This one will take a little bit longer, but we'll get to see how long it takes for our script to handle this. If you're wondering why we're using line.find instead of, there are much more verbose ways to do what I'm doing in Python, it's because find is implemented in C and so runs really fast. So it didn't necessarily matter when we were running our mini version of this, or even the medium version where we just need to go through 18,000 files. But in this case, we're going through a lot more files, so I need something that can actually go through and process all those files quickly. Okay, so we are now complete, so that's not bad. 316, this is in seconds for it to go through and go through every single Azure doc that Microsoft has, for at least it's in Markdown format. Technically, there's also docs in YAML format for FAQ articles and other things. We'll drop that into a DataFrame. And so now we have 23,878 rows, which means we have 23,878 articles. We'll do some normalization on that as well. We want to tokenize this, as we did before. This time I'm going to go and just see how long that takes. I'm kind of curious if... Alright, that's not bad. So 49 seconds to go through 23,000 articles. I think that's pretty good. Let's look at what this is going to cost. Alright, and so this is where you can really see the benefit of the new model. So $21 for me to go and do an embedding of all of Azure Docs, but had I been using the old V1 DaVinci, it would be $10,000. Had I been using Curie, it would have been $1,000. And so, like, really, any of these numbers, a lot of the even like hypothetical use cases I can think of don't really work out for a data set this size with embeddings. But $21, there might be some things we could do with that would be interesting. I am not going to go through, I mean, we can go, we'll take the length, I'll drop anything that is over 5,000 tokens, so we've dropped a little bit. But we still, so that's the total number of articles, but again, if you look here, and let's bring this into Notepad, because I need commas. 53 million tokens there. That's a decent sum. And so if you look at kind of my crude way of doing rate handling, we are not getting to 53 tokens, even if 48 hours from now, once I hit being able to do 3,000 requests per minute, which is kind of the max of what this simple model allows us to do, we're not getting to 53 million anytime soon. So what you need is to be thinking about your tokens per minute of 250,000 tokens, which you can do by doing batching. So there are some articles OpenAI has in their cookbook, a how to handle rate limits, which it gives you some ideas of how to start dealing with this. Also, the other thing to think about when you have a data set this large, or certainly a much larger data set, is you want to be able to retry, you want to be able to do exponential back off. And so the idea of right now with the current incarnation of the script, even if we're using a much smaller data set, if for some reason something goes wrong with the API, we are going to lose everything, even on a smaller data set with this type of script. So really what you want to have is retry logic that as you're getting an embedding back, you're keeping it in some temporary place, rather than the way this works with Panda's apply function is we aren't actually writing to the column until the very end. If you've gone through and you've generated embeddings for 90% of your rows of data in that column, and you get to a record that has an error, you're going to lose the embeddings for everything from that point on, unless you've enabled some type of retry logic. So that's where you want to definitely, as you start scaling up, look at the how to handle rate limits. They also have how to handle parallel processing. So again, if you're in that kind of millions of API requests realm, there are some ideas here of how to handle that. This is really what I wanted to go through. So we started with our miniature, kind of very toy model, showing you how this works with some real world data. We moved up to a kind of a medium-sized model, showing you that this is kind of the limit of what we can do, some very basic rate limit handling within our script itself, and then showing you kind of once you get to a large data set and once you're in the neighborhood of 53 million tokens, you really need to go to the point where you're doing batching, where each request has multiple embeddings requests buried in it, as long as you're keeping it under the total 250,000 per minute token per minute count. Certainly, if this video is helpful, please give it a like. It helps give me a sense of, is it worth investing time in this? It's just something I do on my own time. Thank you so much for sticking around, and hopefully we'll make some more videos soon. Thank you.